Okay, we're on example 5 from section 6.3 on exponential functions. And we now have the function f of x equals 2 to the 1 minus x. Okay, so all we're seeing is one transformation, right? We see something happening inside the function here. Here's the parent function. But now we see that that it's subtraction. We're used to seeing it, though, as x plus or minus something, not something minus x. So let's rewrite it so that it looks like that. So this is the parent. I'll just make a note here. But our function is 2 to the 1 minus x, which I could also write as 2. So the x is negative and the 1 is positive, like this. And then I could factor out the negative. And now it's more clear what's going on. Now we see actually we have inside the function a reflection and a shift, right? So we have a horizontal, both happening inside the function, horizontal flip, okay, which is when we multiply x by negative 1. And we have a horizontal shift. Which direction? Right. So we will add 1 to x. Now, which will we do first? Will we multiply or add first? We will multiply first. Yes, because the order of operations says multiplication first. Again, our points are negative 1, 1 over a. A is 2. 0, 1, and 1a. A is 2. Where do these points go with this transformation? Well, all the y values are staying the same. We didn't say anything about doing anything to y. So each x will multiply by negative 1 and then add 1. So negative 1 times negative 1 is positive 1, plus 1 is 2. Y value doesn't change. Negative 1 times 0 is 0, plus 1 is 1. Negative 1 times negative 1, negative 1 times positive 1 is negative 1. And negative 1 plus 1 is 0. So these are our new points. We have 2, 1/2, 1, 1, and 0, 2. So okay, so remember our original parent function does like this. So we can see that we have spun around that y-axis, horizontal flip, and shifted to the right. So the point that was originally here at 0, 1 has shifted to the right to here. Okay, domain, all real numbers, range, that hasn't changed either, has it? 0 with an open interval to positive infinity, and our horizontal asymptote has not changed. It's still y equals 0, right here, the x-axis. Okay, so that one had a little trick to it. When you see an expression that doesn't quite look like what you're used to transforming, see if you can do a little bit of arithmetic and get it into a format that then you can identify the transformations. We kind of see that again down here. In example 6, we have 1 minus 2x, but our transformations haven't shown that. They've shown like you could take your function and subtract or add something, but not put it in this order. So again, f of x equals 2 to the x, that's the parent function. Let's take what they've given us and see if we can make it look more like what we're used to seeing when we identify our transformations. So what if we just rearrange the terms here and call that negative 2x plus 1? Because the 1 is positive and this is negative. Now we do see them, right? We see the plus 1 on the end outside the function telling us shift up 1. And we have this negation right here that tells us to reflect over the x-axis, right? Because it's outside the function. So we have a vertical flip. We'll multiply y by negative 1. And we have a vertical shift we'll add 1 to y. And of course, multiplication first. 3 points. You should be knowing these by now. -1, 1/2, because a is 2. If a were 3, we'd be writing 1/3. 0, 1, and 1, 2. Okay, so everything's vertical, so none of the x's are affected. So we'll multiply y by -1, -1/2, add 1 to -1/2, and we get +1/2. Multiply 1 by -1, we get -1, add 1, 0. Multiply 2 by -1, we get -2, add 1, -1. Okay, so let's see, we're at -1, +1/2, 0, 0, and 1, -1. Okay, so we have flipped vertically. Remember, the parent function would be doing this. So we flipped it over vertically and shifted the whole thing up 1. Domain, all real numbers. The range has changed. We have a vertical shift. That's always a clue that we've changed something about our y values and their limitations. So now it's from -infinity, low to high, all the way up to +1, but an open interval there, because we will never reach our horizontal asymptote here of y equals 1. So the asymptote is y equals 1.